Like Rick said, my name's Todd Chase with a company called Oceaneering, primarily offshore oil and gas services company. But we have some other basically verticals that I'll get to that we're into. But just my background, started out in the Coast Guard as a pilot, and then transitioned over to the Air Force. And Steve and I were just talking before the panel, like very kind of similar backgrounds in a different way. It's kind of ironic. I guess just being, so I retired from the Air Force where I was the chief of safety at Ellington Airfield in Houston, and went to BP there in Houston, and they started doing a little bit of work up on the North Slope, and just having a background where the last few years in the Air Force, I was a Predator pilot and had some experience, just kind of got involved in some guidelines for BP in the industry back a few years ago. This is probably 2013, 14, and we'll get into that. So basically, still a member of a panel that helps maintain and develop the standards for unmanned aircraft systems within oil and gas. And I'll talk a little bit more about that. But as you can see, these are just some of the things Oceaneering's into, just a little background. And you're like, why is Oceaneering and unmanned aircraft systems? Well, we do have, right now, a large part of our use is within asset integrity and in supporting their teams. And we've taken the approach, as Rick mentioned, of a lot of major corporations where we've just subcontracted out right now and then let the business units develop their own business cases for supporting having, growing their own internal program for UAS application. So it's working out. There's, as Rick mentioned too, there's such a low threshold to entry. You have to be very careful of who's flying these drones around your assets and around your people. And there's, when we first started talking about these industry standards, the FAA hadn't came out with Part 107. And they had some requirements for a 333 exemption, but they weren't fit for purpose for oil and gas, and we saw that right away. So we were able, within about a year and a half, developed industry-wide consensus through IOGP, which is the International Oil and Gas Producers. It's, I think, about 75% of the world's oil is produced with these members, and Conoco, Exxon, Statoil, Total, BP, Chevron, Exxon. It's all the majors and a lot of smaller players. But our platform. So I know Rick was focusing kind of on the FAA. We have to look at it from a global perspective. So the FAA has some. They're on board, and you'd be surprised to know that the FAA might be even considered progressive compared to some countries and regions. Trying to get some UAS applications off the ground in Azerbaijan, in that AGT region is quite a challenge with the government there. And we just have to look at the individual countries' requirements and standards, and then be conscious of the ITAR regulations and compliance requirements when looking at these operations globally. So, we're throwing this in there, and just our perspective is we're not trying to make a dollar on flying the aircraft, the drones itself. It's about the data. We've already have the data management systems, the servers in place. We do all that support for our customers for the offshore data anyways. So our perspective is just the UAS, the drone's just another tool to capture this data for us. And as technology advances, and Rick mentioned the sense and avoid technology, things like that, you see smaller drones, smaller sensors. I think the experience and the training of the pilot will probably get a little less critical. But right now, we very much look at that as an essential element on the experience and training and competencies of the pilot. And I'll get into some ideas where I see it as it's going from our perspective. But so we're coming in here with an idea of having some oversight and nurturing that process when we'll go in and vet an operator to basically, we're looking at the same types of programs for a drone operator that we would expect in our manned aviation operations, and basically doing the same thing that here at Oceaneering that the aviation advisors at BP or Shell or Exxon, Conoco are doing to their unmanned aircraft providers, and just looking at their safety management systems, their privacy programs, their maintenance plans, their operations manuals, their incident tracking, and we'll get into that. I think just from an Oceaneering perspective, one of the advantages of not investing millions into a program to try to support our global needs is we're UAS agnostic. It's such a rapidly advancing and dynamic field, as I'm sure you're all aware. We want to be able to take the equipment that's fit for purpose, the best platform out there to carry our sensors, or the best sensors we can get to collect that data for our clients, and not necessarily try to sell them a certain capability because we invested in this one platform, and that's just kind of I think a very big advantage of our strategy overall. But here we got a few applications. I'm sure you guys are familiar with many more. These are some of the applications we're seeing positive results with the UAS. And just Rick kind of touched on it, but one of the interesting things is you know, with Oceaneering, we have a lot of the rope access folks that come down below the decks offshore to do the inspections below decks on those big oil and gas platforms. There's a thought that these drones are going to put these guys out of work, and it's going to replace them, and to some extent, yes. But we're looking at it as an integral part of future rope access inspections, where you're using the UAV to get under there and identify critical areas or questionable spots that you want to focus on with your crews when you do put them down there on the ropes, or any other type of work, you know, at height, where you can use the UAS to help make your manned operations more efficient and increase that data set that they're collecting anyways for your inspections and other applications. Obviously, these are some of the more popular applications, and we are working with some clients' requests on counter UAV technology, and we're looking at a few different platforms for that, and very surprising capabilities out there for relatively low amounts of money. There's some pretty good systems out there, as Rick was talking about. So getting into this. You know, I just got a quick story. So, like, as Rick mentioned, the threshold entry is so low on these UAV operators. So you're seeing a lot of mom and pop operations get going, and they might have a buddy that works down at the plant, and they're, how do we, you know, now that I got a drone, how do I go get an oil and gas contract? And quick story: when I was at BP at my parents' house outside of Denver in Broomfield there, and their neighbor came to me. He just bought a drone, and he was good. He's out there in the park behind their backyard, just practicing every day. And he's like, Todd, you know, what do I need to do to get a BP contract to fly this now? And you know, I started talking safety management systems and quality assurance programs and maintenance programs and incident tracking, and you know, he quickly lost interest in that conversation, and he says, well, yeah, I got to show you my other business model. And I'm like, you see that RV out in front of my house? And I'm like, yeah, Rob, what is that? He's like, that's the cannabis. I'm like, what, cannabis? He's like, yeah, they just legalized marijuana there in Colorado. He was going to pick people up at the airport and take them out to around all the pot shops for let them smoke up. And I just jotted down my little notepad. Urinalysis drug testing is one of the requirements that we have in our program. So just to be sure, you want to make sure whoever's flying those aircraft, if they're your folks or contractors, look into their programs. See, and sometimes it's difficult just by seeing paperwork. Hey, I got a 107 certificate from the FAA, or I was qualified by this third party. You might want to do a little bit more research into that, especially if you're flying around some critical infrastructure. So it's really not about the drone. The technology is awesome, and I think there's a lot of great companies that have lost a lot of money trying to keep up just in the building of the hardware and technology that's going into these drones. And there's definitely a pivot towards the software side, the analytics, the change detection, the predictive analytics type work. And even these small UAV operators, at 2 or 3 people, they're coming to us and they're like now a data management company. I'm like, they might have hired one software developer. And so anyways, that's kind of what the shift is. But this slide came to me from a company we use as an approved vendor out of the North Sea. We're seeing these commercial operators up in the North Sea that they've been doing this thing offshore for a lot longer than we have, and onshore as well. So you see several experienced companies out of the UK that have been doing this for a while. We try to leverage those companies into our operations. So there's definitely different elements about a good program. They're looking at the folks they hire. Going through the psychometric testing and interviews and flight testing, informal quizzes, and basically sifting through the resumes. They're fairly intensive training programs. There's, as you see by my next slide, there's really no consensus, especially for what's the fit for purpose training program for operations within oil and gas. You see different levels of challenging environments within the industry, and I'm sure other applications as well, where it's hard to say that you go fly this for a week and you're ready to go offshore in the North Sea in 30-foot seas and 30-mile-an-hour winds and fly this off a boat next to some critical infrastructure. So you really got to look at that training program closely. And then as we'll get into in the next slide, and Rick mentioned, there's definite variances in the types of equipment out there between some of the hobbyist type aircraft to some of the more sophisticated industrial oriented UAVs. And what we're looking for is redundancies in critical control systems. With the UAVs, and I think Steve will kind of agree that maintaining that positive control at all times is very, very essential. So it's not only the training of the pilot, but what kind of redundancies do you have? How well does it operate in a GPS denied environment? How good are your pilots flying that manually when they lose a GPS signal? Do they have redundant navigation systems, redundant control systems? Are there return links encrypted? There's a lot of companies that may not want their video intercepted and broadcast out, whether you're doing an emergency response or you're looking at some of your own critical infrastructure. So looking at some of these encrypted capabilities on your not only your command link, but your return link as well. Looking for the ISO quality management systems. It's not a requirement, but it's nice if they have that. And we're looking also into their safety management systems, which we'll get into more, and that they've been looked at by the FAA or Civil Aviation Authority for that country is a plus. And then obviously you can discount that 9,000 hours. It's not, I think they were saying, a little story behind that. I think they counted, they're talking about their company, and they counted one of my buddies' Predator hours in their flight experience. But anyways, their experience is important, especially when you get into these challenging environments and you're working around some very critical infrastructure. You don't want that to be the first time the guy's ever seen a certain loss of control emergency procedure, around this around your infrastructure. Let's see if I can go back one more. So yeah, here's some of the some of the hobby drones. They're great if maybe for some roofing contractors, wedding photographers. Maybe some of the non-industrial rural type applications, even some filming. Although there's some in the film industry, there's some pretty sophisticated UAVs. That's for sure. But some of the size of those things scare me. We're looking at one operator that's got a 30-pound UAV that, it's the size of a small coffee table. I definitely wouldn't want that crashing into me or one of my folks out there. So anyways, that's important, that kinetic risk and just the perceived risk of the size of the UAV when, even though it may not be around populated areas or people, there's still probably some folks at risk there. So, the professional drones, as you see, the big thing I can see is, you're looking at brushless motors. There's really I think there was a claim of an intrinsically safe UAV made in France, but they self-certified that. So from our perspective, these things aren't, we're not going into internal tank inspections without them being gas-free and that type of situation. But we are looking for things such as brushless motors, basically redundancies in the motors where you could lose one or two motors and still maintain control of the aircraft, redundancies in the control links, et cetera. Capabilities with the weather and operating and day, night, wind, rain type requirement, heavy saltwater spray type use. I mentioned all of these things before in the earlier slides, so we'll get into it. And one of the other companies we use they're out of Edinburgh, Scotland. They've been doing this since 2009, and their guys, before they send them offshore, they're trained about a year to a year and a half. They have a tiered training program where they'll go through their ground school, and then they'll put them in some lower risk environments, such rail, wind farm, utilities, and then they'll put them into the plants and do some industrial type flare tip onshore, asset inspection stuff, and then they'll take another check ride before they send them offshore, and that's one of the more challenging environments. So you're looking, these guys will have 500 flights and a couple years a year and a half at least of experience before they're offshore inspecting our assets. So I'd like to see that kind of experience. And it gets a little dry here, but basically there's a few different organizations within oil and gas that have developed or attempting to develop standards within the industry. We're trying to maintain at least some consistency between us. We form our group under this Helicopter Safety Advisory Council, which is primarily the Gulf of Mexico operators here in North America operators, but a lot of these major oil and gas companies operate globally. So it's just a little more nimble environment for us to get things done. And then we push it up to the IOGP. So we're doing a lot of the grunt work for the IOGP on these UAS guidelines. But you also have API. They have a sub-panel for UAS standards, and some of our members are members on that API. And also UK Oil and Gas is put out some very good standards for. They're more inspection oriented, kind of offshore inspection, but they've put out some good work on these standards. And I think what we're going to do now is try to do a comparison analysis and maintain some consistency, at least between these three organizations. And I think that will but it can only take it so far. Eventually, the different companies are going to have different requirements from their aviation teams. Exxon's going to want to see certain requirements. Shell's going to want to see certain requirements in their battery handling program. So we can only take these. These are just kind of broad level, higher level guidance for UAV programs. But just going through briefly some of the elements that we're looking, that we check when we go through is, first make sure they're legal. Are they legal to operate in that country? Any compliance requirements? Do they have, regulatory authorities? Make them show you the permits, and then do a little digging yourself and see what else might be required. Use some, we heavily use our in-country assets and teams when we start looking at requirements and asking and bouncing what the operator's showing me off of what's required in Baku. So, and I'm not going to go through all these since we talked through most of them, but obviously, we like to see, there's been some work in extended line of sight and beyond visual line of sight operations. The FAA has approved a few. I know Precision Hawk has a 330, or it's actually, they're getting away from the 333 exemptions. That there's still a ATC branch of the FAA will do some 333s, but they're moving towards waivers from the 107. It's a waiver process now, and Precision Hawk has that waiver, but they still have to maintain a visual observer down the chain. So it's still the idea of autonomous UAV operations beyond visual line of sight is going to be a ways off, at least from a regulatory point of view, and also from the industry point of view. I think there's when it gets down to the brass tacks, a lot of asset managers are very cautious, very safe, and deviating from tried and true practices, and I think you're going to see at least 3 to 5 years before you see these more. I hate to even use remotely or autonomous operations. At least within oil and gas, I see maybe remotely piloted, remotely monitored operations where even at the Air Force and Creech, and Steve might mention this, where we'd have a couple pilots up front in the container and several sensor operators behind us, and doing multiple aircraft, and you just give your sensor operator a box, and he would fly in that box, and then if you had to take control, or if you ended up having to go kinetic, or they had an emergency, you could just take control of that aircraft. I see a similar scenario for oil and gas, where we're monitoring several UAS operations remotely, but there's always going to be a qualified, experienced pilot in that loop, able to take control of that aircraft if there's a need. At least for the larger, maybe not the micro, the small swarm operations down the road, but I see that probably as the next step before you see extensive autonomous operations, at least within our industry. Maintenance programs, big. Obviously, the OEM may or may not have which is the manufacturer of the drone, may or may not have a maintenance plan, but so you might need to develop one. We look at that, and then to me, the key litmus test for the efficiency and maturity of a UAS operators are safety management systems, and we're looking at this just as we look at a manned aviation operation, except obviously at a scale to fit that smaller operation. But we're looking for things like a just culture, leadership buy-in, incident reporting, incident tracking, quality assurance programs, maintenance programs, things that I've mentioned, and how do these all interact in that continuous improvement cycle that looking at. So, and obviously these are, battery handling program is very important. If you ever see a lithium ion battery on fire or disturbed, it's quite disturbing, especially in an aircraft or in a critical asset. I mean, for those of you not familiar, you can't even take a lighter offshore on these platforms. So they're very. If anyone's ever seen the YouTube video with a nail going through a cell phone or a lithium-ion battery, it's very disturbing, especially if you're in a potentially explosive environment with that. And then emergency response plans. So, just to sum it up, there's policies and procedures behind this tool to operate within oil and gas, and that's the short of it for me.